Hi everyone, welcome to our next video where we will do a deep dive over several stack simulation, uh, primarily about seeing how push and pop results into uh, when you add element, remove it and do several of those together. Then we'll actually see a simulation for infix to postfix conversion, and then we'll actually have a simulation where we'll see that how we can evaluate postfix operation. So all these three, where your ability to understand in and out working of a stack, as well as uh, interpretation around infix and post infix to postfix conversion and postfix expression evaluation could be tested in various ways from 1 marks to 3 marks. So you should pay proper attention. We will actually be doing one quick implementation where uh, we will actually use a stack in a little different way. What is a different way? You looked at implementation of a stack on the top of inbuilt list data structure by providing APIs for push and pop, is empty, and um, pick, which was your ability to look at the top element. There are several questions over the year that have been tested in CBSE where they test a variation of it. That can you find, the largest odd element or largest even element using your stack, right? So we'll see that how we can actually, do some of those, handle some of those codes, because those are tested in 4 to 5 marks setup, and a stack is relatively, in recent year at least, has been tested uh, more frequently and with higher marks than Q. So we'll spend actually larger proportion of today's discussion around these 3-4 items around a stack, and then we'll quickly introduce Q and some of its use cases. So let us deep dive on this stack simulation that we are talking about. So what we'll do is say, as you might see on your screen, right? So these are glass, and say that they are numbered 1, 2, 3, 4, right? So we'll assume that we are going to, uh, place this, glass one after the other, and in between, we'll remove them, and at all the intermediate stages, we'll try and see uh, what is the ordering of our placement. So hopefully that will give you some idea, how our code is working, right? So this implementation is, just I have, taken the same implementation that I was showing you for stack, right? So if you see here, this glass is, right? So this is our glass stack, basically, assigned um, uh, through a list, built-in data structure, right? And then here actually our, basically we are saying that our glass is, say, identified by a number, right? So glass 1 is different than glass 2, right? And on our stack, it will be actually represented using a number. And whenever you are actually having push, we are doing nothing else but simply appending it, right? So this is already a list, and our push simply append out there. Uh, then we are simply having a push message, right? When you have to remove, we are first checking whether the length of this is 0 or not. If it is not 0, we are simply calling pop. Display is actually, repeatedly keep printing unless we reach out towards the end of it, right? And so a stacked glassage, right? So in this particular case, what we are doing is we are we're starting at the ith position from the end, and then we are actually printing towards the bottom, just to ensure that in what order our stack looks like. Clean up a simple deletion, and then in simulation we have just given you some option, right? So to push, you enter a number. To pop, you say, say 2, and so 1 to 5, right? 1 for push, 2 for pop, 3 for display, 4 for display stack class, and 5 for quit, right? So with that in mind, let us actually play through this simulation and see what happens. So say we are actually saying that we want to push a glass onto our stack, right? Now it is saying that enter the glass number to push. Let us say that our glass number is 1, right? And we ran into some issue, missing one argument, positional argument num, where it will push glass number. Give us a minute. It should be okay. What is our cleanup routine? We are assigning classes back to this. Let us see. Let us fix it. There might be some issue. Let us rerun through it. It is asking for our choice. So we say 1. Then push class onto our stack. Enter the class number to push 1. Okay, this is fine. Then again it is saying what next you want to do. Do you want to push again? You said yes, right? Say now you want to push 2 number glass, right? So what we have got so far, at the bottom 1 and 2 at the top, right? So if you want to look at stack display, let us enter 4, right? And what it is showing, glass 1 is at bottom 1 position, glass 2 is at the bottom 2, right? So glass 2 is at the from the bottom. Yes, that's fine. Let us say that now we want to pop, right? So pop is not in our hand, so 2 will get out. And let us say again we want to kind of look at our glass, right? So we are only left with 1, right? So 1 2, let us say that now we are entering 3. So enter your choice. Again say that we are entering glass number 3, right? Then say we are entering glass number 4. So what you can expect? 1 3 4. Let us see the display. What happens? Now we are again having 1 3 4. Can you see it here? Glass 1 is at the position 1, glass 3 at the position 2, and glass 4 is at position 3. Now if you pop, what will happen? You will actually see 4 coming out, right? So you have actually popped 4. Now if you want to actually again display, what will be having? 1 and 3, right? 1 and 3, you can see the output here, right? Again if you pop, what you will get? Now you will only 3, right? Only 1, 3 is popped. So if you want to look at, it's only 1. Now if you again actually pop, that's where you are now, it should be empty, right? So if you want to do again pop, your class is empty and the simulation is done. Oh no. So enter your choice. Now we are saying 4 glass are empty, right? Let us quit it. Hope you have liked this simulation. Okay, great. Now we are going to look at our Postfix Evaluator, right? And you'll also get an idea how this is being implemented on a stack. The code is already there. You really don't need all of this to be memorized. Just try and understand how this is working. More often than not, you'll be asked to evaluate some theoretical postfix expression in your exam, right? So in this evaluator, we are first asking that give us an expression, but we are expecting that operators and operands are separated with a space, right? Then we are basically, splitting all the tokens. Our stack is initialized to this. Now, as you know, what we are doing in this case, as you read through token, if it is a digit, right, that's the first case, right? If it is digit, we append it, right, on the stack. Okay. Else, if there are not less than, not more than two operands, we are in an erroneous scenario. And if you are getting an operator, right, then what we are going to do, we are going to take operand 2 and operand 1, just like the algo that we are discussing in last video, right? So you have got the operand 1 and operand 2, and then you look at, right, what your operator was. If it was plus, minus, into, division, right, whatever it was. So, if it was plus, you have done plus. If you are minus, you have done minus. If it is into, you have done into. Very simple, right? If it is a divisor, you check that operand 2 is not 0 and then you divide, right? And then you get the answer and then you continue, right? Eventually, what you do, you append the result and continue. So that's what we were talking about, right? On the stack, if you are actually getting a digit, we will push it as it is. If you are getting an operator, you will actually try and push the last two operands and evaluate the result and compute the result and push it again. And you will continue till the stack is empty, right? So let us see, how it works. Postfix evaluator. Okay. So Postfix evaluator. Let us say we are saying 2, 3, right? 4. Let us say we are saying that 4 into 3, 2, 12, right? And 12 divided by 2, 6, right? And then 6 and 5, and say if you are doing a plus, it should be 11, right? Oh, sorry. So 2, 3, 4, then into operator 3 into 4. Let's see what is happening. Interrupt posterior expression separate operator, place 2 onto the stack, place 3 into the stack, and you can see the stack part here, right? What your stacks are. So this is the simulation, right, where you can look at each step, right? So 2, 2, 3, 2, 3, 4, and pop 3 and 4, and you multiply, so that is 12. Pushing result in the stock 2 and 12, right? We did actually an error. There was no space out here, right? So that's the reason it has actually failed. Let us try it out. So there is a limitation we want to so say 2, 3, 4 into 3 into 4, 12, right? 12 divided by 2, 6, plus 5, 11, right? Let us enter. So you got 2, 2, 3, 4, 2, 3, 4, 2, and okay, so we have changed the order. So 12 and then 2, 12 is popped, and we are dividing it by, I think what we should be doing here is, when we are doing 12 by 2, right? So I think here it should be operand 2 is 0. So what is operand 2? Operand 2 is the first one, right? Here it is 2. Operand 1 is first one. So it should have been actually, let us print here, let us see what these operands are. Print operand 2, and then we are having print operand 1. Okay. And let us say that for our identification we are printing something here, something there. Okay, let's evaluate this again. So what we're saying, 2, 3, 4 into 3 into 4, 12, right? 3 into 4, 12, and then we want to divide it by 2. So, oh, okay, and 6, and then we are saying that plus 5 should have given 11. We are getting something different. So let's look at our output. 12, 2. Okay, so first we have 12, and then we are getting 2, right? I think so. Order is different. Yeah, that's the operator. This is correct. It was just missing. So this is a correct output, right? You can play around it, right? And the next one is actually our infix to postfix. So let's again look at the code, right? It is actually saying that inter and infix operation. It is simply splitting a array, then it is creating actually an output queue and an operator stack, right? It is also defining precedence for plus minus. So plus and minus are at same level, and into and divisor are at same level. Why this will be needed? Any quick answer? Because whenever you get a lower precedence operator, or a stack, all the lower precedence, all the higher precedence, and equal one will be taken. So if token is digit, we are actually simply kind of keeping the appending it there. Else if this is a precedence, right? It's else if token is in precedence, right? So then we are checking it, and we are kind of popping all the operators which are actually there, right? And in that case, we are simply taking all those combination and outputting it to the output Q1, right? And eventually when you get any matching this, we actually get everything out there, and otherwise you actually keep doing as it is. So pretty similar to that, little more complex. No worry, we are just interested in understanding. So 3 plus 4 into 5. What we want to do? 3, 4 plus, right, and 5 into, and say by 2, right? What you got? 3, 4, 5 plus 2 and into. Great. So actually we have looked at all these three simulation, simple stack. You can actually, I'll upload these, and you can actually in the description I'll give a link to it. You can play around, modify it. But important is actually you make yourself comfortable with infix to postfix and postfix evaluation. Okay, now so this is the variation that I was talking about, right? So we are saying that write a program to create a stack for storing only odd numbers out of all the numbers entered by the user. So if user enters actually even number, we are not going to add them. We are simply going to add only odd number. Then we say that display the content of the stack along with the largest odd numbers in the stack, right? So here there is a hint also given in your textbook that keep popping out the elements from a stack and maintain the largest element retrieved so far in a variant. And we are going to repeat it till a stack is empty. So basically if you see here, right, we can take this glasses glasses implementation, right, and let us try and actually kind of implement. I know that okay, I mean in implementation in this, let's just have a look to save our time. So in push, what we are doing is simply are checking for whether this number is odd or not, right? If it is odd, then only we are appending it, right? Pop is simple, no difference. Is empty, exactly the same. Display exactly the same. Now, how you find the largest one? So actually what we are doing, we are creating a temporary stack, right? And what we do out here is, while our stack is not empty, we keep popping, right? And when we are getting a new number, we are checking, right, that whether this is greater than our existing or not. If it is, then we are changing the largest, and then we are actually kind of appending this item to the temporary stack, right? And eventually when we are done, we again push it into our stack from the temporary stack. So 1 2 3 4 becomes 4 3 2 1, and when again you enter, it becomes 1 2 3 4. It's a kind of OAN operation to get the largest, right? And here we have actually played, more like the simulation that we are having, right? So you can check 10, 13, 15, right? 27, 29, and then say 3, 17, 14, whatever it is, 17, right? So it is eventually giving you largest odd number as 29. This is correct. I think the only thing that you have to actually do is simple variation in your push block, right? When you check that number is odd, then only you add. And to find largest, you are actually doing 2 push and pop, right? So you keep popping till your element is empty, and while individual elements are there, you actually keep checking whether it is greater than your largest or not, right? And then you output that and you recreate the stack. So this is important because more, as long as you make yourself comfortable with this implementation of a stack, right? In your exam you can expect a similar variation. That's why actually I'm saying that make yourself comfortable. So we are done with part of the um, stack things, right? That we were trying to. Let us you know um, look at our queue. So we'll actually quickly go through our queue and kind of try and uh, uh, finish this presentation. Okay. So what we were doing in case of our stack, right? A stack was a LIFO data structure, right? That was the last in, first out. And the application that you saw was, say for example, calculator, right? Where you have to do your postfix evaluation. And we looked at our practical use cases, right? Say this one, or the book one, right? Where actually the element that has been put last has to be taken first. And there are actually so many use cases around that. There is another important use case where you want the person who has entered first to be served first. For example, when you go to a doctor, right? Say that there is no prior appointment. So worst thing that you like is you came last and you are treated first, right? That's the VIP culture. So in a normal culture, what you have to do, you expect that since you have come first, let you to be served first. And what is the way of doing it? Imagine, right? You are going to a doctor queue, right? So you came first, you sat on the first seat possible, right? And then the next guy came, right? What you can do? So either you keep moving everybody, on the front seat, or you say that, uh, you know, uh, the person who is going to the doctor seat is happening from on one end, and the set of people who are coming new, they'll be actually sitting at the other end, right? So there is a concept of front and row. When the first person comes, wherever he sits, right, at one end of the same bench, whether left or right, that you are going to call it front. And from there on, just behind him, the next person, behind him, the next person, right? And you'll be asked in doctor room from the front part of the. So that's what the queue is, right? Um, in today's world, right, your web servers, you also have a topic around that, right? And many of the take a stack that you are having, right? Those are managed through queue, right? So at many of your streaming other scenarios, even the Netflix that you are seeing, right? In many of those scenarios, um, you know, your events are queued somewhere, and then they are actually served from there. So the example that you are seeing in this image is a variety of load balancer, and ways where items are consumed and produced from one end of it in the order that they arrive. So let's quickly introduce queue. So we saw the LIFO. This is a FIFO, first in, first out, right? This is an ordered linear data structure that follows the first in, first out strategy. First element added to the queue will be the first one to be removed. What are the key components here? Front indicates the beginning of the queue where deletion happens. Rear indicates the end of the queue where insertions happens, right? Its applications are in task scheduling, handling requests in web server, the example image that you are seeing, printing jobs, etc., etc. More important, your say doctor appointment, doctor patient one, your restaurant, sort of uh, visit, your restaurant actually reservation or whatever, right? Your, many of those things. Say your flights, right? They are managed in a queue. The basic operation here are, we are going to add an element at the rear of the queue, right? We are going to remove an element from the front of the queue. So removal happens, that we call DQ, is deleting from the queue happens at the front. Addition to the queue, that is in queue, happens at the rear of the queue. Peak retrieves the element at the front without removing it, just like peak of the stack is empty. Whether it is empty, when it will be empty, when rear index will be equal to the front index, right? And when it will be full, when uh, rear minus front, right, will be equal to the sum of those length allowed here. So insertion deletion difference from a stack is at a stack both push and pop was happening on the same end, that we call top. In case of queue, they are happening at different end, front and rear. Implementation perspective, again, this is a very simple implementation around list. So when we are including item at the front. When you are dequeuing, right, always what we are doing is we are actually dequeuing item from the 0th index, right? So if you see, we are saying queue.pop. Queue is nothing but a simple inbuilt list, right? When we are seeing peak, if your queue is not empty, we are simply calling 0th element of that is from the front, right? And when it will be empty, when length of queue will be 0. So some example in Q10, right? In Q20, 10 and 20. If you want to DQ, what will happen? 10. If you want to pick, what is there? 20. Great. Similar to Q, there is a concept called DQ. The idea behind DQ is where you can insert and do modification at both ends. You don't have a separate front and rear concept. So basically, DQ is a double-ended queue. This is a data structure where elements can be added or removed from both ends, but not in the middle. There are input restricted DQ where insertion happens only at one end, but deletion is allowed from both ends. And there are output restricted DQ where deletion happens only at one end, but insertion is allowed from both ends. So simple application, palindrome, same from both ends or not, right? Undo operations in software, browser history management, those kind of things. So what its implementation is going to be, our insert, right, as 0th element, then we have insert at rear, we have delete from front, we have delete from rear, and check for empty, right? So if you insert at rear, if you insert at front 10, 20, and then if you are trying to delete from the front, you have to this 20, right? Trying from deleting from here, you have to this 10. So double-ended queue is another thing. You just make yourself, just quick queues, right? uh, this is a linear list of elements in which insertion and deletion takes place from different ends, right? So that is queue. Operation on a queue are performed in FIFO order, first in first out. Insertion operations in a queue is called what? In queue, and deletion is called DQ. Deletion of element is performed from front end. Now ASDF are present in the queue and they are deleted one at a time. See the sequence of element received. So you inserted A, right? So you get in the same order ASDF. This is a data structure. Elements can be added or removed at either end, but not in the middle. That's a DQ that we are just discussing. Now he's talking about a DQ is JDX, CV, and B elements received after deletion are Z, B, VX, and C. So what is the sequence of deletion operation performed on the queue, right? So JDX, CVB you have done, and after deletion you are inserting, you are deleting from beginning J, and then whatever is deleting left XCVB you are actually deleting from front, that is B, and then you are deleting from front, that is V, then you are deleting from rear, that is X, and then C, right? So delete from both front and rear, right? So you can look at this example. So great. With this we have actually come towards the end of this quick introduction around queue. We talked about operation, the FIFO order, the difference from stack where this can be done. Your addition and deletion are done on the different end, and then we introduce a cousin of this, that is DQ. We looked at some of the use cases, and there are some of these concepts are tested but less frequently. So we'll do another previous year question paper, specific to data structure and elbow, and do join that because that's going to be very, very interesting. If you are enjoying this video, please like and subscribe, and hope to see you in our next video where we'll be talking about algorithms, that is sorting and searching.